Hello Middle Street. Today we will explain Unit 2, Lesson 2, Electric Current and Cells. There are two ways to generate an electric current. Number 1, electrochemical cells. They are cells in which the chemical energy is converted into electric energy. For example, dry cells and batteries. It produces direct electric current. Number 2, electric generators or dynamos. They are the devices in which mechanical energy is converted into electric energy. For example, electric generator or dynamo, it produces alternating current. Types of electric current: direct electric current and alternating electric current. Direction of direct electric current flows in one direction from one pole of the cell to other pole, then returns. Alternating electric current variable flows in both directions. Electrons flows in one direction, then flow in the opposite direction. Intensity of direct electric current is constant, and in alternating electric current is variable. Source of direct electric current like electrochemical cells, simple and dry cells, but source in alternating electric current like electric generator or dynamo. Transferring of direct electric current only for short distance, but in alternating electric current for long and short distance. Direct electric current can't change to alternating, but alternating can change to direct current. Uses of direct electric current: electroplating, electrolysis, some electric machines. But in alternating electric current, in lighting houses, electric appliances. Methods of connecting the electric cells in the circuit. Number 1, series connection. The electromotive force of a group of different dry cells connected in series equals the sum of electromotive forces of these cells. So E battery equal E1 plus E2 plus E3 and so on. Number 2, the electric motive force of a group of similar dry cells connected in series equals the number of cells N times electromotive force of one cell. So E battery equal N times E1. So the relation between electromotive force and the number of cells is directly proportional. When electromotive force increases, the number of cells increase. Number 2, parallel connection. It is done by connecting all the positive poles together and all the negative poles together by a copper wire. There is one common positive pole and one common negative pole for the battery. The electromotive force of the battery equals the electromotive force of one cell. So E battery equal E1. For example, a battery consists of 3 cells. The electromotive force of each cell is 3 volts. Calculate the electromotive force if the electrodes are connected, number 1 in series, number 2 in parallel. Number 1 in series, E battery equal N times E1, so equals 3 times 3 equal 9 volts. But in parallel, E battery equal E1, so equals 3 volts only. Another example mentions the voltmeter reading in each of the following when the electromotive force of each cell is 1.5 volts. Figure A, E battery equal N times E1, so equal 3 times 1.5 equal 4.5 volts. In figure B, E battery equal 1.5 plus 1.5 because the battery is connected in parallel, so equals 3 volts. Figure C, E battery equal 1.5 plus 1.5 equals 3 volts. Questions? Give reason. The alternating current is preferred to the direct current because it can be transferred for long distance and it can be changed into a direct current. Number 2, some electric cells are connected in series in the electric circuit. To obtain a battery, the electromotive force of it is high. Exercise. You have 4 electric cells. The electromotive force of each is 2 volts. Show by drawing only how can you connect them to obtain a battery of an electromotive force of 4 volt with 3 different ways. Thank you.